In this video, we're going to get an introductory overview of data-driven investing. Firstly, what exactly is data-driven investing? Ultimately, it involves creating and implementing investment strategies that are statistically valid, right? So it's not about whether I think it's a good investment strategy. It's not about whether you think it's a good investment strategy. It's about statistical validation. So data-driven investing essentially leverages a combination of math, statistics, as well as data to drive our investment decisions. And that could be, for instance, which stocks to invest in, or how much to invest in, or, which stocks not to invest in. But again, it's helping us make those investment decisions without relying almost entirely or exclusively on personal opinions. And so fundamentally, the idea is to start with a notion or a premise, or what's formally called a testable hypothesis, and then testing and validating that notion or that premise or that hypothesis statistically, right? So we're seeing whether this idea or whether this notion has any merit, right? Whether this premise or this hunch or this idea is statistically valid, right? So is there any basis to it? Is there any merit to the argument or the idea? Now, why should we bother with using data-driven investing? Well, because it reduces the need for subjectivity, and it reduces the need for personal opinions when it comes to determining whether or not an investment strategy has any merit. Right? So is there any basis to an investment idea or an investment strategy that we want to implement or are considering implementing? Because as you're now hopefully quite familiar with, there's a lot of uncertainty in financial markets, right? There are a lot of variables at play. And many of those variables can't be predicted. So when it comes to determining whether an investment is worth our while, whether a stock or a portfolio of stocks will perform in the way we expect them to perform, personal opinions are only going to take you so far. Right? Because, who knows what the future holds. Now, it's not like the statistics is some sort of crystal ball, right? It's not going to accurately predict the future entirely. But what it will do is bring in far more certainty vis-a-vis just personal opinions and subjective opinions. Right? So it's not about eliminating uncertainty, but it's about reducing uncertainty. So data-driven investing removes the guesswork, and it can reduce uncertainty because it forces us to focus not on what we think may happen in the future or what we feel might happen in the future, but instead it forces us to focus on what's actually in the data. And then it forces us to see whether the stuff that's in the data is statistically valid. Right? So does it actually hold statistically, or is it just there by random chance or random luck? And because it forces us to explore what's in the data, and because it forces us to take a significantly more objective and sort of unbiased data-driven approach to investing, it can create a solid foundation for a meritocratic way of thinking and investing. In other words, it allows us and empowers us to say goodbye to, hey, this is a good idea because I say so, and say hello to, this is a good idea because, well, here's the proof in the data and here's the proof in the statistics, right? So it's taking a much more scientific, meritocratic approach to investing vis-a-vis just because someone claims to have experience or claims to have, loads of knowledge or, claims to have some sort of knack with investing in stocks. Now, that's not to say that experience doesn't matter, and it's not to say that knowledge doesn't matter. The problem is when we blindly follow experience and when we blindly follow knowledge, right? Because we want to be able to question that experience, because the validity of experience changes with time, right? What's valid in terms of experience today may be completely irrelevant, say, 10 years down the line or 20 years down the line. And the same holds true for many aspects of knowledge as well. Now, of course, there are some exceptions. For instance, certain knowledge, certain concepts, for instance, remain the same over decades or over centuries. But it's still important to question knowledge, right? And it's still important to question experience. And that's what data-driven investing ultimately allows you to do. It's about questioning what we see. It's about questioning what we observe in the data and finding answers that are actually statistically sound and statistically valid. And so perhaps most importantly then, we should use data-driven investing because it helps reduce unnecessary risk when investing. Right? Because yes, it doesn't remove all the uncertainty, and yes, it's not some sort of crystal ball, but it certainly does give you a much clearer understanding of what exactly is at stake, and more importantly, perhaps, understanding whether or not it's actually worth our while. And so now that we have a sort of basic understanding of what data-driven investing is, and more importantly, why we should bother using data-driven investing, let's now think about what the data-driven investing process actually looks like. So if we were to think about data-driven investing in a sort of systematic way or a logical step-by-step process, then here's what it might look like. We start by developing an investment idea or an investment thesis, right? And this is literally just an idea, okay? It's a notion, it's a hunch. In this instance, at this stage, no idea is crazy. So you can literally think of any idea because at this stage, everything's open, right? We're just considering, what might be a plausible investment idea or a good investment idea. And once we have that investment idea, we then transform it into what's called a testable hypothesis. And we're going to talk about what exactly this is later on, but the idea is that this is a more sort of formal expression of the investment idea. It's a formal expression which we can later test and validate by using the data, by using the math, and of course using statistics. Okay, but we start with an investment idea and we then convert it or transform it into this thing called a testable hypothesis, after which we can go about extracting and cleaning relevant data, right? Because when it comes to real world data, as you're somewhat familiar with by this stage, since you've been working with a little bit of real world data, it's almost never sort of clean and just ready to use, right? So real world data tends to be quite messy, and it does require a little bit of cleaning or what's called pre-processing before we can actually use it to kind of test and validate hypotheses or to explore whether an investment idea has merit. Okay, but we extract and clean relevant data, and it's at this stage where we can estimate some sort of relevant measures and finally then test and validate the core hypotheses that we set out in step 2. Now, of course, I've kind of rushed through points 4 and 5, but that's because we're actually going to go over each and every one of these points in a tad bit more detail just now. So let's actually think about that investment idea, so developing an investment idea or an investment thesis. Well, we do this by using a combination of sources. Right, so this could be knowledge, this could be experience, or information that's available in the news or the research literature, or internet forums or social media posts, or a conversation with a mate. It really doesn't matter, right? There are multiple sources of information. And this is also why I said it's not like knowledge doesn't matter and it's not like experience doesn't matter, because knowledge, experience, and information from a variety of sources can be incredibly valuable in developing these sort of creative ideas, right? And thinking about what might potentially be a worthwhile investment strategy or a lucrative or profitable investment strategy, right? Because this is a creative aspect. It's about thinking outside the box. It's about imagining and, really being creative about what might turn out to be a good investment idea or a good investment strategy. And again, at this stage, no idea is particularly crazy, right? Because remember, it's not like we're just going to go out and invest the money, because we've got a great idea. No, we're actually going to test out that idea and see whether it has any merit, right? If there is anything worthwhile there. So at this stage, it's okay to have totally crazy or, ambiguous and really out there or far-fetched ideas, if you will, because we can then test it out in the data and see if they genuinely are far-fetched or if they actually have any sort of merit, right? So again, at this stage, you can really let your imagination and your creative juices, so to speak, really flow, right? Because we're just developing or thinking about an investment idea or an investment thesis. And because we actually want to test this investment idea, we actually want to validate this investment idea, we transform it by formally expressing the investment idea or thesis into what's called a testable hypothesis. And again, that's just a formal way of expressing an idea or a hunch or a notion or a premise, but it's expressing it in a way where we can actually go out and test it in the data. Okay, and again, we're going to talk about how we actually go from this stage over here, where we go from developing an investment idea, to this stage over here, where we then formally express it into a testable hypothesis. There is actually a little bit of a step between these two. So really, you would start by developing an investment idea, and then after that, you would kind of create a sort of research question, if you like, from that investment idea, right? So you would express your investment idea in the form of a question, as in, does this effect matter? Or can this effect be profitable? Or, is this particular effect lucrative? So you would essentially take your investment idea, rephrase it as a question or, strictly as a research question, and then transform that research question into a testable hypothesis. Okay, but again, like I said, we're going to go over these steps in much more detail in individual videos. But for now, it's just important that you get a sort of broad overview of what the data-driven investing process actually looks like. Okay, so once we've got a testable hypothesis, or indeed multiple testable hypotheses, we then go out and extract relevant data, or we collect relevant data. And of course, the data that we collect or extract is very much a function of what the core hypothesis is, right? So, I don't know, if your hypothesis or investment idea is something to do with, say, the sentiment of firms, then you're going to be collecting data that relates to some sort of sentiment, right? Or you're going to collect data that helps you get to sentiment estimates for companies. Similarly, if, for instance, your hypothesis is about whether gender matters, so for instance, whether the gender of CEOs matter, or, whether investing in companies led by female CEOs is more profitable vis-a-vis firms led by male CEOs, well, then you're going to collect some data relating to the gender of CEOs. Right, so the specific data that you collect will, of course, be very much a function of what the core hypothesis is, or what the underlying research question or underlying investment idea or investment thesis is. But, at this stage, once you've got your idea, once you've got your hypotheses, you then go out and collect that data. And you would either sort of hand collect the data if, the data isn't available in a neat and clean, ready-to-use database, or you would extract or download the data from some sort of database if, of course, it's available in that format. Now, while the specific data will, of course, vary depending on the hypotheses being tested, it's pretty common for us to work with returns data across, a variety of different hypotheses, right? At least in the context of data-driven investing. Not finance as a whole, but just data-driven investing in particular, right? Because, of course, within the scope or within the realms of data-driven investing, much of our hypotheses, much of our investment ideas or thesis will involve securities, right? Will involve assessing whether an investment strategy is lucrative or profitable or, meaningful. And so naturally, we're going to end up working with returns data because guess what? As you learned in the investment analysis fundamentals, returns are just the amount of money you make expressed in percentage terms. And so, if you're trying to evaluate an investment strategy, well, of course, you want to see whether you're going to make any money from it. And so naturally, returns data is very commonly used. Okay, so we tend to work with returns data in addition to the data that relates to a given or specific investment idea. For instance, I don't know, CEO gender or sentiment, whatever you like, right? Whatever the core investment idea or thesis or hypotheses that you're testing out. And like I was saying earlier, when we work with real-world data, it's almost never just clean and ready to be used as is. We often have to clean it, right? We often have to prep the data, and we do this by cleaning the data or pre-processing it or processing it. I mean, there's a whole host of different terms that people use to describe this process, but in a nutshell, it's about transforming the data and getting it to a stage where it's ready for us to analyze the data. right? So we're getting the data to a stage or in a format where we're able to do things with it. For instance, calculating portfolio returns of firms that have a certain characteristic that we're looking to test. Or indeed, running some sort of statistical regression. We can't just run statistical regressions on the fly. We kind of need to prep the data in a certain way before we can do that sort of statistical analysis. Okay, so the fundamental idea is to just prep the data or get it ready for analysis, and we do this by cleaning or pre-processing or processing the data. And although this particular step can seem a little bit tedious and it can seem arguably boring, at least to some people, this is perhaps the most important step of the data-driven investing process. And the reason for that is because, different courses, different sources, different statisticians, different lecturers, different analysts, different researchers will tell you different things about, the best model for a given statistical test, or the best approach to take for testing a given hypothesis, or, to test whether a given investment strategy will work. There's almost always more than one way to test and validate hypotheses, to test and validate whether an investment strategy is worth pursuing. The models range from incredibly simple and easy to incredibly sophisticated, machine learning or artificial intelligence type models, if you like. Right? So models can be as simple or as sophisticated as you like. But the results that you get from the model, regardless of how sophisticated they are going to be utterly useless if the data that you've fed it, if the data that you fed the model is useless. Okay, and in fact, within the data science community, within the data science field, if you like, there's this term GIGO, which is given a lot of importance, and, understandably so, right? Rightly so, because GIGO, which stands for garbage in, garbage out, essentially says that if you feed in a model garbage data, then the results that you're going to get are also garbage, right? So garbage in, garbage out. If you feed crappy data, you're going to get crappy results, or you might well get results that seem meaningful or that seem intuitive even, and exciting even perhaps, but they're utterly meaningless because the data was fundamentally flawed to begin with. So again, I must stress, although this particular step can seem tedious, it can seem painful, and to some people in particular, this particular step can seem a little bit boring and mundane even, I really cannot stress the importance enough of this particular step, because this is what ultimately makes or breaks your models. This is what ultimately makes or breaks your investment analysis when using a data-driven approach, right? So cleaning the data, processing the data is an incredibly important step because, again, GIGO, so garbage in, garbage out. So you want to make sure that your data is ready, it's usable, and it's in good form before you actually get into the analysis. And, aside from that resulting in you having meaningful data, the other massive benefit is that this step really helps you gain a solid understanding of the data that you're working with. And knowing and fully understanding the data that you're working with becomes increasingly important as you increase the size of your sample. Right? So as the data that you're working with gets bigger and bigger, it becomes more and more important for you to know your data inside out and really understand the data inside out. Because the bigger the data is, the more holes there can be in the data, right? So the more issues there can be in the data, the more discrepancies there can be in the data. And with large data sets in particular, it's easy to miss those discrepancies. It's easy to miss those holes in the data. And, I face this myself, right? When I'm working with large data, when I'm working with millions of observations, for instance, it's, of course, almost natural in some instances to miss certain things, just as a result of working with those large data sets, right? Where you've got so many different things going on. But what helps you reduce the risk of missing important things, and what helps you reduce the risk of having holes in your data or discrepancies in your data, is knowing and fully understanding your data. And cleaning and processing the data just helps you get one step closer to really knowing and fully understanding your data. Okay, but hopefully you do see the importance of this particular step. once you've extracted the data and once you've cleaned the data, we're then ready for the fun stuff, right? Which is estimating our relevant measures. For instance, I'll use the example of the CEO gender again. So, if, for instance, we were looking to see whether firms led by female CEOs do better than firms led by male CEOs, then at this stage we'd be calculating, for example, the returns of firms led by female CEOs, right? So we'd be creating portfolios of, say, firms that are led by female CEOs, and we'd create separate portfolios of firms that are led by male CEOs, and then we can kind of compare the returns or the performance of the different types of portfolios, right? Those that are comprised of firms led by female CEOs versus those that are comprised of firms led by male CEOs, right? So the relevant measures that we estimate will, of course, vary depending on the core hypotheses being tested. But this stage is particularly fun, right? Because at this stage you start estimating things, you start, getting your hands dirty, if you like, and really playing around with the data. And so, at least for me personally, this is one of the most fun parts of data-driven investing. And, hopefully you'll also find this as much fun as I do, if not more. But, fundamentally the idea is about estimating some sort of measure that relates to the core hypotheses that we're testing, right? Over here, we've got the example of portfolio returns of firms that display a certain characteristic. And so, of course, we just talked about the example of portfolios of firms led by male and female CEOs. But, equally the same could apply if you were looking to estimate the impact of sentiment, for example, right? You would create portfolio returns of firms based on their level of sentiment. And in fact, this is something we've actually done in a sister course of ours on investment analysis with natural language processing. And so, again, the point is really that the specific measures that you estimate will, of course, vary depending on the core hypotheses that you're testing. But you can only really get to the stage once you've got your investment idea, which you've transformed into a testable hypothesis. And of course, once you've extracted the relevant data and then cleaned and pre-processed and prepped that data. Okay, and once you've then got these relevant measures for your hypotheses, you're then finally ready to test and validate the core hypotheses. And how do you actually test and validate it? Well, again, this kind of depends on what the core or underlying hypothesis is, right? So it could be something as simple as a t-test, or it could involve more formal regressions, right? Be that univariate regressions or multivariate regressions. Again, the specific things, the specific tests that you use, the specific tools that you use is very much a function of what the underlying hypothesis is, right? But regardless of which tool you use, the fundamental idea is to validate your notion, right? It's to validate your thesis or your idea or your hypotheses statistically and empirically. Hopefully all of this makes sense. In summary, we learned that data-driven investing involves creating and implementing investment strategies that are statistically valid. The idea is to start with a testable hypothesis of an investment idea or an investment thesis, and then test and validate that hypothesis statistically. Right? Test and validate it empirically, relying on the data, relying on the maths, and relying on the statistics. And of course, we talked about the 5-step data-driven investing process, where we start with an investment idea, transform it into a testable hypothesis, extract and clean the relevant data, estimate relevant measures, and finally test and validate the core hypotheses. Importantly, I should say that although the 5-step data-driven investing process that we showed you is quite systematic, it's quite logical and sort of sequential, the real world often isn't so systematic and so logical, right? And so it's not uncommon to jump between steps, right? It's not uncommon, for instance, to go back a step or jump a step and then come back to the preceding step at a later point in time. That's pretty normal when working in the real world, because guess what? The real world is quite messy, right? So when you're working with real world data on real world problems, you're going to encounter a multitude of different issues and problems that you need to troubleshoot before you can actually get on with, the core step in the data-driven investing process. And so the point is, don't be disheartened if, you find yourself jumping from pillar to post, moving from one step of the data-driven investing process to another, without it going in a sort of sequential or systematic order. That's normal. But the idea of having this 5-step data-driven investing process, the idea of having this sort of systematic overview, is that it prevents you from running around like a headless chicken, right? Because you have at least some idea of where you are in the data-driven investing system, if you like, and you also have an idea of where you want to get to, right? So you have some idea of where you are and where you want to get to, and that can help prevent us from running around like headless chickens. Okay, hopefully all of this makes sense. If any part of this video is not quite clear, please do watch it again before moving on any further. That's because later on, we're sort of going to dive deeper into the specific aspects of data-driven investing. So we're going to dive deeper in, for instance, how to develop an investment idea or an investment thesis and how to create a testable hypothesis. But I'm going to assume that you're more or less all right as far as understanding a broad overview of the data-driven investing process, right? And I'm going to assume that you more or less have a good understanding of where we are and where we're going in the context of data-driven investment analysis. Okay, but that's enough from me for now. Have a go at the quiz, and I'll see you in the next video.